Okay, so our lesson today for the top of your composition book notes is 3-4, dividing rational numbers. So we just talked about the other day or yesterday multiplying rational numbers. Today we're going to look at dividing them. So this first part, before we begin, we have to talk about something called multiplicative inverse. Multiplicative inverse. So the product of a number, which means the answer to a multiplication problem, so of a number and its own multiplicative inverse is always 1. So they give us an example here. So 2 over 3, a number's multiplicative inverse, or another key word for that is reciprocal, means you just flip it. So 2 over 3, we would flip it and say, okay, well, its inverse is 3 over 2. It's inverted, it's flipped. So if we multiply those, 2 times 3 is 6, over 3 times 2, which is 6. 6 over 6 equals 1. So 3 over 2 was the multiplicative inverse of 2 over 3 because if we went back and multiplied them, it equaled 1. So that's kind of the definition of multiplicative inverse. So now looking at example 1, it just says find the multiplicative inverse of each number. So 7 over 16, well, its inverse would be 16 over 7. Because if we multiplied those and simplified, we would get 1. So on A, the answer is just 16 over 7. B has a little bit of, you have to do something first because we can't flip this when it is a mixed number. So we first have to make it improper. We've got to multiply on bottom, add on top. So 3 times negative 6 is negative 18 plus 1 more, so we get negative 19 over 3. Now, when you take the multiplicative inverse of a negative number, you're going to flip it, but you still keep the negative sign. Because remember I said when you multiply them, it has to equal 1. I didn't say it could equal negative 1, just 1, so positive. So you have to do a negative times a negative to get a positive. So if it starts out negative, when we take the multiplicative inverse, we just keep that negative sign and flip it. So the multiplicative inverse on this one is negative 3 over 19. So what I want you to do now, you are going to attempt 1A and 1B at the bottom. All you're doing is finding their multiplicative inverse right now. Example 1, we have multiplicative inverse. So you're just taking a number and using its inverse because how you check it is if you multiply it by itself, its inverse, you should get an answer of 1. Not negative 1, positive 1. So the multiplicative inverse of negative 7 over 9 is negative 9 over 7. You keep it negative because if we were to multiply these, a negative times a negative is positive. 7 times 9 is 63. 9 times 7 is 63. 63 divided by 63 is 1. So that's how we know that negative 9 over 7 is our answer. That's the multiplicative inverse. So on 1B, 2 and 1 over 12. Well, to find the inverse, we first have to make it an improper fraction. So we multiply on bottom and add on top. 12 times 2 is 24, plus 1 more is 25 over 12. We haven't done it yet. All we did was make it improper. Now, to find the multiplicative inverse, you flip it. So our answer on B is 12 over 25. So now we're going to be finding the quotient. Example 2 says on A, 1 over 9 divided by 5 over 12. Okay, so when we are dividing fractions, we can't do that. It just doesn't work because when you're multiplying fractions, you're already getting smaller. So we can't do this. So what we have to do is make it a multiplication problem. So we can't just change it from to divide to multiply. That wouldn't work. That'd just be all of a sudden, poof, changing stuff. So we have to do 1 over 9 times the reciprocal or multiplicative inverse of the second number. So this problem would become 1 over 9 times, then we flip this one to get 12 over 5. Now we use our same multiplication rules that we've been using, that we used yesterday. We can either multiply straight across and then simplify, or we can cross cancel first. So they cross canceled with 9 and 12. They divided them both by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So then 1 times 4 on top, which is 4. 3 times 5 on bottom, which is 15. So on A, we get 4 over 15. Now on B, we are dividing by a whole number. And this little piece over here, this little sticky note says, don't forget when you're dividing by a whole number, rename it as an improper fraction first, which means put it over 1. So we put 8 over 1 because now that's an improper fraction. Now we change it to a multiplication problem. Don't get confused and think when you put 8 over 1 that you've done the reciprocal, because you haven't yet. So it becomes 3 over 7 times, we flip that to get 1 over 8. Now we can cross cancel and multiply. So 3 times 1 is 3. 7 times 8 is 56, because there was nothing we could cross cancel on that one. So our final answer is 3 over 56. So what you're going to do, you're going to write down problems 2A and 2C. I've circled them for you. And pause the video and just work those two problems out. Then I'll go over them with you.
Example 2, we have 1 over 3, or 2A, divided by 7 over 15. We can't divide fractions. It just doesn't work. So we multiply them. I think Mr. Chadwick used, what did he say, keep, change, flip, or keep, change, flip, KCF, I think is what he would call it. So you change it to a multiplication problem, but we can't just change the sign. We have to then use the multiplicative inverse of our second number, so we flip it. Maybe keep, change, flip. I think that's what he would use, KCF, like Kentucky Fried Chicken. Okay, so now we can either multiply straight across or cross cancel. I'm going to cross cancel on this one. So 1 and 7, there's nothing I can take out of those. But 15 and 3, I can take a 3 out of both of those. 3 divided by 3 is 1. 15 divided by 3 is 5. So on top, I now have 1 times 5, which is 5. And on bottom, 1 times 7 is 7. If you multiplied, you would have gotten this, and then you would have then had to divide by 3. On to C. Okay, so first of all, 11, to make it a fraction, we put it over 1. But we got to change it to a multiplication problem. So don't let that confuse you. If you put 11 over 1, don't let that be what you put here, because I now have to flip it to where it's 1 over 11. So now we can check to cross cancel. 3 and 11, there's nothing I can take out of that. 4 and 1, there's nothing you can take out of that. Anytime there's a 1, you can never take anything out of it. So this one, they're already simplified. So 3 times 1 on top, which is 3. 4 times 11 on bottom, which is 44. And that is simplified. All right, now we'll look at the next one.
So now example 3. So it says find -4 and 2/3 divided by 3 and 1/9. So before we can multiply, divide, do anything on this one, we first have to make these mixed numbers improper fractions so that we have one number on top and one number on bottom. So -4 and 2/3, we would multiply on bottom. 3 times -4 is -12, plus 2 more would be -14 over 3. Then the second one, we do the same thing. 3 times 9 is 27, plus 1 more is 28. So we have 28 over 9. Now, from here, this is still a division problem. We cannot divide two fractions. So we have to flip it and multiply. We use our multiplicative inverse, or the reciprocal. So we take -14 over 3 times, flip that second fraction, and it becomes 9 over 28. Now we can cross cancel. So looking this way, this diagonal, 9 and 3 both have a 3 we can divide out. So 3 divided by 3 is 1. 9 divided by 3 is 3. Then if we look at the other diagonal, 14 and 28, we can actually, you could take a 2, a 7, or in this case, you can actually take a whole 14 out. So 14 divided by 14 is 1. 28 divided by 14 is 2. So now we have -1 times 3 on top, which is -3. 1 times 2 on bottom, which is 2. So -3 over 2. We then have to go back and simplify it. That is -1 and 1/2. So since these types of problems kind of have 2 extra steps on them, I will only make you do one of these on your own. So I want you to work on 3A only. Pause the video, work it out, and then I'll go over it with you.
So I only made you do one from this section because it's going to take us a little longer because we have mixed numbers and it's a division problem. So we have several steps to solve this one, so I only gave you one. So first let's go ahead and make these improper fractions because I can't find the multiplicative inverse of that until we flip it. Or, excuse me, until we make it improper. Then we can't solve this until we change it to multiplying and flip it. So now, we'll go ahead and make these improper. We multiply on bottom, add on top. So 8 times 6 is 48, plus 3 more, 49, 50, 51 over 8. You keep your denominator. It's still a division problem. I haven't changed anything. Now I'm going to do the same thing. It's negative. We keep it negative. 4 times 4 is 16, plus 1 more is 17 over 4. So now we can change it to a multiplication problem. Keep, change, flip. It's still negative. Now it's negative 4 over 17. So now we can try and cross cancel. 8 and 4. Let me switch colors. And I want to check something on the calculator because I'm almost positive. Yep, okay. So anyways, 8 and 4. We can take a 2 out of that or a 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Let me switch colors. Even if that's all you did and then you multiplied and simplified, that is still correct. But I double checked in my calculator to make sure. 17 is a prime number, but it actually goes into 51. So 17 divided by 17 is 1. 51 divided by 17 is 3. It's one of those weird numbers that just happen to work out. So if you didn't get that, that's okay because it was one of those weird ones. So on top, I have 3 times negative 1 now, which is negative 3, over 2 times 1, which is 2. If the top is bigger, we're not done. But this one's pretty easy because we know it's going to be negative. 3 divided by 2, 2 goes into 3 one whole time, and you get 1 left over out of 2. Negative 1 and 1/2 is our answer on that one. Now let's look at, we're going to skip 4 and look at example 5.
So example 5 says find 5 over 3ab divided by 15 over abc. Write the quotient in simplest form. So we have lots of letters in this one and they don't tell us what any of those letters equal. So first let's just kind of look at what all's happening here. So on bottom here we have 3 times a times b. Over here, we have a times b times c. We're dividing two fractions, so we know we can go ahead and change it to a multiplication problem by flipping this second fraction, its inverse. So it will become 5 over 3ab times abc over 15. So from here, we can actually cross-cancel a lot of stuff. Just like if we had a 3 up here and a 3 down here, they would both cancel. So we can do that with letters, okay? Because A is the same thing as A. So I can cancel this A and this A. Well, if you notice, there's also a B that they both have. We can cancel both of the A and the B. There's a C up here and there's not a C down here, so it can't cancel, okay? And there's a 3 here and no other whole numbers up here, so we can't do anything with that, but this AB canceled. So looking the other way, I have 5 and 15. I can take 5 out of both of those. 5 divided by 5 is 1. 15 divided by 5 is 3. So I am left with 1 times c on top, which is 1c, which is what they have here, because remember when it's 1 in front of it, you don't necessarily have to put it. We can clearly see that there's 1c there. On bottom, I have 3 times 3 now, which is 9. So all of that, all our stuff canceled, and we are left with c over 9. We don't know what c is, so that is as far as we can go. I know this kind of takes a little bit of thinking, so I'm just going to give you one of them. I want you to try 5a. Okay, you don't have to worry about b, just do 5a. Pause the video, try that, and then I'll go over it on the board.
On this problem, again, I only gave you one because this one takes a little bit more thinking. We have 5ab over 6 divided by 10b over 7. And they don't tell us what a and b equal. So we're just going to get this as far as we can. And that's going to have to be good enough. So it's a division problem that we want to change to multiplication because you can't do anything when you're dividing fractions. So we keep, change, flip. KCF, baby. Mr. Chavik told me that's what he used to say. KCF, baby. Okay, so now we look at cross-canceling. 6 and 7, nah, there's nothing we can take out of those. So I'll look this way. 5AB and 10B. Okay, looking at just the 5 and the 10, I can take something out of that. Let's go ahead and look at the other. Here's an A, no A, can't do anything with that. Here's a B, and here's a B. I can cancel those B's. So now I have 5 and 10. I'm going to take a 10 out of, or excuse me, a 5 out of both of those. 10 divided by 5 is 2. I don't have a B anymore, so all I have here now is 2. 5 divided by 5 is 1. All I'm left with here now, I'll just rewrite it up here, is 1A. Because the A didn't cancel. So now on top I have 1A times 7. Now don't be confused. When we are adding things, if one has a letter and one does not, you cannot add or subtract them. But because we're multiplying, this means times A. So it's still going to be times A in our answer, so you can multiply. So 1A times 7, so 1 times 7 is 7, so that will be 7A, because it is still times A, over 6 times 2, which is 12. So even though we couldn't get a final answer because we don't know what A is, it could be -1, 0, or 1,000. So we keep it 7A over 12. That is our simplified answer.